First of all, I will give an introduction for our group project. There are two general approaches to curve fitting that are differentiated from each other based on the amount of errors involved with data, that is, least square methods and interpolation method. Least squares is used when the data contains a large amount of errors or noise. Tuberculosis is one of the world's leading killers of a single infectious agent. Tuberculosis disease is an infectious disease which is commonly affect the lungs, but it can also affect other parts of the body as well. About 2/3 of the world's TB cases are in the Western Pacific region, of which Malaysia is part of it. There are three objectives for our group project. That is, first, to solve the curve fitting, second, to distinguish the two approaches to curve fitting, and the third, to apply least squares method in curve fitting problems. In this project, the data was collected from the website of data.gov.my that showed the number of tuberculosis cases in Malaysia weekly in 2014 by states. This is the data for our group project, where weight as an independent variable X and number of tuberculosis cases in Malaysia as dependent variable Y.
A linear least squares is used to determine the best fit straight line that suits a set of data points. The best fit line is defined as the line producing the smallest possible total error obtained by adding the squares of the residuals. This is the data to determine the number of data, sum of x, sum of x squared, sum of y, and lastly is sum of. There are 7 steps to find the least square straight line. Step 1. Let fx equals to a0 plus a1x. Step 2. Write the normal equations in a matrix from 2 by 2. The formula is matrix of n, summation of x, summation of x, summation of x squared times matrix of a0 and a1 equals to matrix of summation of y, summation of xy. Step 3 is determine the number of data and summation of x, summation of x squared, summation of y, and summation of xy. Step 4, for each xy, calculate the summation of x squared and summation of xy. Step 5 is substitute all this value in step 3 into step 2, and we will get n equals to 53, summation of x equals to 1431, summation of x squared 51,039, summation of y is 34,711, and lastly is summation of xy is 687,005. Step 6 is solve for a0 and a1 by applying the Cramer's rule. So the least square straight line is fx equals to 423.12 plus 1.5972x. By plotting the data of x and y, the best fit straight line is y equal to 423.12 plus 1.5972x.
Quadratic function. This is the table of data that we get using the Excel to calculate all the coefficients that needed in this function. In this function, the coefficient that we needed is summation of x, summation of x squared, summation of x cubed, summation of x power of 4, summation of y, summation of xy, and the summation of x squared y. We use the Excel to calculate all the coefficients because it made us more easier to calculate all the summation in a short time. The step of the function is step 1. Degrade m equal to 2. The general equation for this function is fs equal to a0 plus a1x plus a2x squared. This is the equation for the curve. Step 2. Write the normal equation in the metric form 3 multiple 3. The formula for the metric form is m plus 1 multiple m plus 1. Because of the m we get is 2, so 2 plus 1 multiple 2 plus 1 equal to 3 multiple 3. And this is the metric of this function. Step 3. Calculate the coefficient needed in the metric. So n equal to the total number of the data that we use. So the number of the data that we use is 53. So we insert the value that we get in the Excel into the metric. So n equal to 53, summation x equal to 1431. The summation of x squared equal to 51039. The summation of x cubed is 2047761. And the summation of x the power of 4 is 87633963, and the summation of y is 24711. The summation of x multiple y is 687005, and the summation of x square multiple y is 2513745. And this is the metric form of the function. Step 4. By solving the metric using the EQN mode, we will get the value for A0, A1 and A2. We get A0 equal to 480.9. A1 we get negative 4.7063, and we get A2 equal to 0.1167. So the last step for this function is step 5. Fit the value above into the equation. So the general equation for the function is fs equal to a0 plus a1x plus a2x squared. So we substitute all the value that we get into the equation, and we get the equation for the function is fx equal to 480.9 minus 4.7063x plus 0.1167x squared. So this is the function. So this is the equation for the curve. Best fit curve line. This is the graph for the equation 480.9 minus 4.7063x plus 0.1167x.
For the alternative function, we use exponential function. This is because exponential function is better than other functions in representing our data. An exponential function describes the relationship between input and the output using repeated multiplications by initial values to obtain the output for any input. Exponential functions are commonly used to model the real world, such as population, radioactivity, and others. These fit our dataset. Equation for the exponential function is y equal to a exponential to the power of bx. There are several steps in this solution, which is step 1, we need to identify the expected function, that is y equal to a exponential to the power of bx. And step 2, we need to identify the unknowns, that is a and b. And step 3, we need to linearize the equation of y equal to a exponential to the power of bx until it becomes ln y equal to ln a plus bx. Step 4, we need to transform the data, that is y equal to ln y, a naught equal to ln a1 equal to b. Step 5, we need to identify the normal equation. It is n summation of x, and summation of x squared times a0 a1 equal to summation of y and summation of xy. 6. Based on our data, we need to determine the respective values for n, summation of x squared, summation of y, and summation of xy. From here, we can get n is equal to 53, summation of x is equal to 1431, summation of x squared equal to 51039, summation of y equal to 324.544, and summation of xy is equal to 8795.079. Step 7, we need to substitute the values that we get from step 6 into the equation 1. That is 53, 1431, 51039 times a0 a1 equal to 324.544, 8795.079. For the step 8, we need to solve for the coefficients of a0 and a1. So by using the equation mode, we can get a0 equal to 6.053 and a1 equal to 0.0026. Step 9, we need to solve for the model unknowns. So from here, we can get a0 equal to ln a equal to 6.053. So a will be 425.3873. Meanwhile, a1 equal to b, which is equal to 0.0026. Step 10, the expected function that we will get by using the values of a and b from step 9 is y equal to 425.3873 exponential to the power of 0.0026x. So this is the graph for the exponential function. This is the best fit exponential line.
Sum of square of error, SSE. The formula for SSE is summation of absolute error square. SSE for linear function. Because we get the equation in the previous slide for the linear function is y equal to 423.12 plus 1.5972x. So we substitute the value of x into the equation to get the value for new equation y1 new. After we substitute all the value x into the equation, so we calculate the absolute error, which is y1 new minus 1. So the answer for the absolute error with power of 2 to get the SSE. So after we calculate all the absolute error square, we sum all the data to get the SSE for the linear equation. So the SSE for the linear equation is 476.475.2315. SSE for quadratic function. Because we get the equation for the quadratic function is y equal to 480.9 minus 4.7063x plus 0.1167x squared. So we substitute the value of x into the equation to get the value for y2 new. After we substitute all the value x into the equation, we calculate the absolute error that's in y2 new minus y for this quadratic function. After we get the value for the absolute error, we power the absolute error with the power of 2. So we sum all the absolute error the power of 2 to get the SSE. So the SSE for the quadratic function is 44873.8520. SSE for exponential function, because we get the equation for the exponential function is y equal to 425.3873 exponent and exponent power of 0.002cx. We substitute the value of x into the equation to get the value of y3 new. After we substitute all the value x into the equation, we calculate the absolute error, that is y3 new minus y. After that, the value of absolute error will be power of 2. After we power of 2 on the absolute error, we sum the absolute error to the power of 2 to get the SSE. So the SSE for the exponential function is 482565.3556.
As a conclusion, least square regression is a method to draw a best fit line depending on a set of data points. Regarding the data collected, we choose V as an independent variable which represents X and number of tuberculosis cases in Asia as a dependent variable which represents Y. A single curve mirrors that represents the trend of the data. In this project, we apply 3 approaches. The approaches we used is linear function, polynomial function, and lastly is exponential function. The general equation used for least square line is fs equals to a0 plus a1s. The least square polynomial line is fs equals to a0 plus a1s plus a2x square plus dot plus a and sm, and the least square for exponential line is y equals to a e power of bs. Therefore, using a fitting polynomial of method, it is more efficient to get the equation least square compared to linear method and alternative method using the exponential. Polynomial function is more accurate in plotting the graph.